Alright, getting started on this review. It wants us to take and write the slope-intercept form. The line slope-intercept is the y equals mx plus b form. So whatever we do, we're going to have to solve that for y. It gives us the slope, so we're going to drop it in right here. It gives us that y-intercept, so we can drop it in for b. We'll get y equals negative 2 over 3, x minus 1. On number 2, very similar. They tell us the slope, they tell us the y-intercept. We have y equals m, which they give us at 4. X plus b, which they make is negative 5. You can write that plus minus. It's algebraically accurate, but as always, I would tell you just write the minus. On number 3, graph the line. They're going to give us a point at negative 4, 2. So here's negative 4, 2. And it tells us we have a slope of 1 over 3, negative. So that means down 1 over 3, down 1 over 3. You'll notice we just started that line. We didn't have to get the y-intercept. The y-intercept for us when we graph is simply a point to start and count from. Since we've already got a point to start and count from right here at negative 4, 2, we don't necessarily need to take and solve that for y. Looking at number 4, same thing. They're going to give us a point to start from at negative 1, 3. It's got a slope of positive 2, so up 2 over 1. I'm out of space, so I'm going to go backwards a little bit. Give myself some points to make a nice line. Alright, they give us another one. Now these two, you'll notice, they want slope-intercept form, so they want it solved for y, but we do not have the y-intercept. So I'm going to have to start in point-slope form. The y minus y1 is equal to m x minus x1. What point-slope form will do for us is it gives us an equation to drop our information into, but we'll have to take it and solve it for y after we've put everything in. So I'll have y minus 0 is equal to negative 2, x minus negative 2. You'll notice I changed that double negative to a positive. Makes my math just a little bit easier. The only thing I have left to do is take and distribute this negative 2. The 0 will simply fall off, and I'll get y is equal to negative 2x minus 4. On number 6, very similar to the previous process, we'll just get y minus 7 is equal to m, which is 4, x minus 1. I'm going to distribute that 4. Y minus 7 is equal to 4x minus 4. Add the 7 to both sides, and I'll get y is equal to 4x plus 3. And we'll be all done with that one. Let's go on to that next page. Again, we got a little bit more on slope-intercept form. So this first one, I'm going to take and just rewrite them as points. You can take and leave them in function notation form, but it's the same. You've got your x in the same position, you've got your y in the same position. If you'll rewrite them as regular points, sometimes that helps out. The first thing I need to do, I got to get my slope. I don't have a slope, so I'm going to go 4 minus 3 over 6 minus 4. Make sure you keep that order. If you use the 4 to go first for your y's, use that 6 to go first in your x's. That gives me a slope of 1/2. Now that I got my slope 1/2, I'm going to take it, drop it into that point slope equation. Y minus, I'm going to use this point, y minus y1 is equal to slope x minus x1. Distributing out 1/2 can be a little intimidating, but half of 4 is 2. So that makes my numbers a little bit prettier to look at. So I'll have 1/2 x minus 2. I'll add that 3 to both sides, and I'll get y is equal to 1/2 x plus 1. And we're finished with that equation. The second one, again, I would start off using a point. It's no different. It gives you no new information, but it looks a little better. And sometimes that can make all the difference. I'll have 1 minus 4 over negative 2 minus 4. We'll get some negative numbers here. Negative 3 over negative 6. That'll reduce to a positive 1 over 2. And I will choose one of the 2 points. I'm going to pick 4, 4 because both numbers are positive. There is really no reason to pick one or the other aside from personal preference. And sometimes having no negatives or maybe getting the smaller numbers, sometimes there'll be a choice that makes it easier for you, but either choice will work. We're going to take that 1/2, we're going to distribute it to both sides, and then I'm going to add the 4 to clear up my equation. I'll get y is equal to 1/2 x, and we'll get a plus 2 right there. Slide it on up. All right, we want slope-intercept, we want to be parallel to these lines, and we want to run through this point. All right? Parallel to this line, run through this point. Now, if we want to be parallel to y equal 1/2 x, negative 1/2 x rather, we want a line with a slope that is negative 1/2. That's the only thing that necessarily has to be true. Is that slope has to match for it to be parallel. So I've got my slope and I've got the point that I need on my line. It's just y minus y1. Again, that double negative turns into a positive, equals m x minus x1. It's the very same process we just got through doing. The only difference is we're going to identify that slope because of the parallel. All right? We're going to identify that slope because it needs to be parallel to this other line. Everything else exactly the same. You get your point, you get your slope, you drop it into your equation, and you solve for y. Everything else exactly the same. Looking at number 10, we want to be perpendicular. Now if I have a negative 1/2, I need the opposite reciprocal of this number. So instead of negative 1/2, I'm going to have a positive. And instead of 1/2, I'm going to have 2/1. It's exact opposite. So negative, positive. 1/2, 2/1, that's perpendicular. All right? This is the slope that I need to use. I'm going to use that same point of 2, -5. We'll get y minus -5 is equal to 2/1. I'm going to leave off the fraction because it's easier to do your distribution with a regular number than it is a 2/1. Sometimes students in my class get confused. So if you've got that whole number, once you start messing around with equations, I would leave that fractional piece off just so it's a little bit nicer for you to move everything around. Again, personal preference. Makes things a little bit easier sometimes. We'll go right here to number 11. What's the equation of the vertical line that passes through the point 0, 2? Remember that vertical lines, if this is my grid, all right, this is my axis, vertical lines have one value for x. We're going to change colors. One value for x. All right, so example, if this is, let's say this is 3, 0, x is 3 on all of these points. We'll go 3, -7 down here. X is always the same number on a vertical line because you're not moving left or right. You're not changing x. So when you look at the point and they want to know which vertical line, or the equation for the vertical line, x is not going to change. So this is your x value. One of the x values on this line is 0. That means all of the x values on the line has to be 0. So this line, if I were to draw it, I'm going to draw it in orange so you can see it. This line is going to be right here on the y-axis. It's going to be vertical, and it's where x is equal to 0. All the points on this line, x is equal to 0. That's what makes it vertical. You're not changing left and right. You're not changing that x value. Horizontal line, same point. What is the equation of the horizontal line? Again, draw my axis, and again, I'm going to give you an example in blue. If I've got a horizontal line that looks like this is your example, all of the y values are not changing. So example, if this is 0, 3, this would be, let's say this is 3, 3, and this over here would be -3, 3. All right? So that's my horizontal line. You'll notice all the points, we're not going up or down, so y is not changing. Y is not changing. It's always the same. So when you look at this example, on this one, your y value for the point at 0, 2, the y is equal to 2. So that means at all the points on this line, y needs to be equal to 2 in order to make it horizontal. So my answer here is going to be y equal 2. And we'll cut the video.